Hey folks, welcome back for the next section. So we're talking about elements, compounds, and mixtures in this lesson. In the last one, we were able to run through physical and chemical changes, properties, and we started physical changes, and today we're going to get into chemical changes as well. This also is going to be broken up into a couple of parts because there are a couple of activities that go along with each section. So when we start to go through elements, compounds, mixtures, and talk about elements, so it's the simplest form of matter that has a unique set of properties and cannot be broken down. It's only one kind of atom. So what we're going to do is we're going to break apart each of these three things. So really there's like four parts here, starting with elements and just kind of working our way through. And like always, before I get too far in, just to remember, if you're copying down notes or if you're putting stuff in margins off of printed notes, reading online, taking your own notes from there, whatever you need to do to kind of make sure that you understand and can kind of follow along with recalling some of this information. So cannot be broken down. It's only one kind of atom, okay, for elements. So when we talk about elements in general, we talk about what we can find on the periodic table. Okay, simplest form of matter. It cannot be broken down any further. So if we had, hydrogen, if it exists in nature, it's H2 because it's known as what's called a diatomic molecule. It just means that there's two of them that exist in nature. Each one of them, though, is a hydrogen atom, and I can't break a hydrogen atom down any further. So compounds are the next one. That's where we think about our water, like H2O. Two or more elements that are chemically combined in a fixed proportion, and it can be broken down. So two or more types of atoms. So for instance, if I were to talk about water, water could undergo a process called electrolysis, where it passes an electric current through, creates enough heat that it will actually separate hydrogen and oxygen into their respective gases. So compounds can be broken down into simpler forms, or really into whatever atoms they're composed of. So as a note, a chemical compound can be broken down into its simpler substance, but it can only do it through chemical means only. Okay, so physical, remember, is like separating it with your hands. I can't separate compounds like water, for instance, just by pulling them apart. It has to undergo some sort of chemical process. So to break down compounds, we have to have this chemical change. So when we mentioned separating water in that last slide, passing it through with electrolysis to break it apart. So a chemical change is our next kind of definition term. It's a change that produces a new substance with new properties. So it's not the same thing as it was before. For instance, if you were to see a piece of paper be lit on fire, that piece of paper then undergoes a chemical reaction. I can't get the original piece of paper back again because it's changed over. Rust in a vehicle would be another example of a chemical change where I can't get the original type of compound or type of material that was there before. So there's some different things here that are kind of evidence that we can see that recognizes when chemical changes occur. So for instance, we can see like a color change or an odor change. We can see temperature change or formation of a precipitate. There's light given off. Maybe it's difficult to reverse, like we can't get the original material back again, the same composition. That's not necessarily the same thing as saying that we can take a piece of glass, like say shattered glass, because that's physical, right? The composition of it didn't change. When we say difficult to reverse here, it just means that we can't get the original composition back to the way that it was. And bubbles or formation of a gas is formed. So these are just some different clues that we can have where we can recognize what a chemical change looks like. Okay, so you can see in some of the pictures on the side where we have like color changes, or in the middle here we have some bubbles that are given off. Even on the bottom you can kind of see some clumps that are down here that kind of look like it's like a solid structure, so that'd be like your precipitate, or pouring a couple things together and getting that color change kind of pop out of it. So a mixture is a physical blend between two or more substances, so therefore it can be separated physically. So mixtures, normally the easiest one that I refer to is something like sand and rocks. You just pull the rocks out, you have your sand left over, or pizza, for instance, where you can pick apart the pieces that are there, and they can all be separated by physical means. So mixtures really get broken down into two pieces. We can say that solutions are one. You've got homogeneous mixtures, which kind of the idea behind that is it seems as one phase. It only has one visible part that you can see. So I think like Kool-Aid, for instance, you look at it, you only see one visible phase that's there. Whereas the difference between a solution and a heterogeneous mixture, heterogeneous mixtures, you see two or more phases that are there. So there's your pizza example where you pick apart the pepperoni that's on it, for instance, and you could separate the mixture with physical means. So that kind of leads us into this little chart. It's on page 50 in the textbook if you can't quite make it out. I would like for you to have this chart as something that you can refer back to. Just to break apart all the pieces we've talked about so far. So for instance, try to treat this flow chart like starting right up at the top with matter, and then we can classify matter in different ways. So matter can be broken up, moving down into here is talking about like substances. So they have a definite composition, they're homogeneous in nature, and then they can be separated or classified either as elements if they're found on the periodic table, or compounds as groups of those elements or groups of atoms. Likewise, if there's something that you can't see the symbols for, like for instance if it doesn't say H2O or it doesn't say C6H12O6, then if it doesn't show you those compounds right away, we're left kind of wondering, okay, what is it, right? And maybe the other way kind of gives us a bit of an indication. So this has mixture of substances or a variable composition. So do you see how the substance part, really, if we start combining multiple substances together, that's where we get these mixtures from. And then the green arrow going across just says, mixtures can be separated physically. We can take them apart into their pieces. Now, mixtures can also be classified based on if you can see, say, one visible phase going through the list, and so also called a solution, a homogeneous mixture, or we can see that we have our heterogeneous line where we have a heterogeneous mixture, it's non-uniform, it has these distinct pieces to it, so that's where I think like, okay, the pizza example, for instance, kind of pops to mind. So there's different ways that we can classify these. It would be good to have this in your notes just to kind of refer back to it. You now have all of the pieces as of here to be able to go through and take a look at that first worksheet. Okay, so I would pause the video here. I'd take a look at assignment number 2. That there's a couple of parts there that you just have to classify. Is it a physical property or chemical property? Is it a physical change or a chemical change? And then you're just identifying, is it a is it an element, a compound, a solution, or a mixture? And there's kind of definition terms themselves on the worksheets that kind of explain them. So give them a try, and then you can come on up and check and see how you did. And I am going to move on, so just pause the video here, work on those, come back to this point. Okay, so the next section, separating mixtures. We've got differences in physical properties. They can be used to separate your mixtures through. Processes such as things like filtration, distillation, they're examples of separating mixtures. Other things include mechanical separation like settling and extraction. So different areas to go through when we start to talk about separating our mixtures out. So I'm just going to go through a couple of them. We're actually going to pause partway through here because there's an activity for you to work on as well. So filtration is one. So the idea of filtration is it removes a solid phase from a liquid phase. So in your day-to-day life, hopefully there's something that you've seen before that you can kind of relate this to. We think of, say, making a cup of coffee, for instance. You'd have your coffee beans or your tea bag where you have this solid structure in there, a solid material, and then we pass liquid through it to kind of drain out a little bit of the substance in there. Okay, removes the solid phase from a liquid phase. All it's ever left is just the solid particles. It takes the liquid and kind of passes them through. Okay, so it removes a solid from a liquid. Our next one is distillation. Distillation separates liquids, so based on their different boiling points. So let's say, for instance, that we had two different liquids, something was mixed together. You can see this says like homogeneous mixture of liquids, and then it has a couple little granules on the bottom of it. If you can make out what it says here, the blue part says the blue liquid boils at 80 degrees Celsius, where the yellow liquid boils at 100 degrees Celsius. So I could use this process, right? We can go ahead and use distillation and bring this up to a boiling value that might work for blue. So let's say that we brought it up to something like 90 degrees. Well, 90 degrees is enough to get the blue liquid to boil. So the blue liquid would boil. The yellow liquid, which wouldn't evaporate yet because I haven't hit that 100 degrees, kind of separates in this fractioning column and allows the blue liquid to boil upward, and then it hits this idea here where it says cold water out. So once it moves up, it cools down a little bit because it's away from the heat source enough. And as it cools, it starts to move down through here, right through this condenser, and ends up in your flask on the side and what you would want. So you can see there's like a cool water chamber all around here, right? And so cold water out, cold water in, would end up allowing this to cool down again back into a solid form where it was a gas. So separating liquids based on their boiling points. The next one is chromatography, so it's separation and purification. This one is pretty cool because it's something that we can do in the room. So I would pause the video here, this is the end of it anyway, and at this point you can kind of come up, get or print off the activity sheet, and I can explain how to go through the next step when you're ready. So we'll pick up kind of after here with some more separating things and move on to the last topic, but you are ready to go with the information as of right now to start the next activity on chromatography.